Hello, this is the Genuinely Approachable Sudoku for the 22nd of February. It is Hotcakes by Philip Newman, so let's take a look at the rules. We got some interesting looking thermos here. Normal Sudoku rules apply, so place the digits 1 to 9 in every row, every column, and every 3x3 box. Thermo, digits along thermometers strictly increase from the bulb to the tip. So we have some thermos here that we are, okay, well, they have to increase from bulb to tip. So for example, a sequence such as 1, 4, 6, 9 works. This works because every digit is greater than the previous one. But there is also a secondary rule of consecutive pairs. Digits in cells separated by a white dot must be consecutive. So those two digits, for example, are consecutive. You could have 9, 8, for example. I mean, obviously not because of the thermals, but this is a possible pair of thermal digits. Alright, and those are all the rules. There's also no negative constraints, so those two digits could be consecutive if you want them to be. With that, let us just begin solving. Right, so obviously the gimmick here is that every digit on a thermometer must be forming a consecutive set of digits. So let's start with this one over here. Because 1 can't be on the thermometer, and those two digits must be lower than 4, they must be 2 and 3. And so in fact, you don't actually need the dots here to prove that this is just a 2, 3, 4 thermometer. Same here, these digits must be greater than 6 but can't be 9 because of the column, so they must just be 7 and 8. I could probably do those thermals because while they do seem pretty short, they are linked by another consecutive set of digits. Now, can I prove that it must be that this is smaller? This is smaller than that. If this is a smaller one, then no, this could be the smaller one. You could have something like, let's just use 4 here. You could have something like 4 with 9 here. Yeah, okay. Yes, it's possible to have this be a smaller digit. Okay, I thought you would have to force this to be a set of 7 digits in consecutive order, but you don't have to have them be that. In fact, I think they could repeat as well, like those two digits could be the same. I think, not entirely sure. Alright. Well, where to next then? Well, this digit actually can't be 1, 2, 3, 4, 6 or 7. It can't be as high as 8 because there are no two digits greater than 8, and it obviously can't be 9 either for the same reason. So it must just be 5. Therefore, this must be greater than 5 and consecutive to 5, so it must be 6 followed by 7. Okay, where does 7 go in this box? Well, 7 has to go in the middle. 7 can't be on thermometers because both of them don't work. 7 here forces an 8 there, which breaks. 7 here forces a 6 here, which breaks. So 7 must be in the center. Alright. What about 8 in this box? Well, 8 in this box can be in a lot of places. In fact, should I just mark this? Yeah, I could just mark this triple down. These are 4, 8, and 9. That can't be 4, that can't be 9. Okay, what else do we have? Probably the same thing on the other other side. This can't be 9, 8, 7, 6, 4, or 3. It can't be as low as 2 or 1 because you can't have that many digits lower than them. So it must again be 5 followed by 4 and 3 because they must be consecutive. We can now place 3 in the center for the exact same reason. 3 can't be here because it forces a 2 here. 3 can't be here because it forces a 4 here. So this must be 3. And I guess this has to be a 1, 2, 6 triple. And actually we're starting to feel very X windmill like, where any two opposite cells are summing to 10. Does seem very X windmill. But we can't prove that yet, so let's take a look at other things. This, for example, can't be 1, 2, 3, or 4, so it must be at least 5, but it could be as high as 7. So should I mark them down? Not entirely sure. Maybe look at the longer thermals. I haven't looked at those yet. This could be as low as 1, but it can't be as low as 1 because a 1 here forces a 2 there, which breaks. It can't be 2 or 3 either, so it is at least a 4. Oh, there actually isn't a connecting dot here. So those two digits don't have to be consecutive. That's really interesting. But I want to say that this can't be 4. Because if it was 4, this would have to be 5 because it can't be 3. Those two digits would be less than 5 and consecutive, but because of the 1 and 3, you can't actually find a set of consecutive digits lower than 5. Like you can only have 2 and 4, but they're not consecutive. Which is a bit convoluted, so maybe I'm not supposed to do that. But at the very least I can say this isn't 4. It probably could be 5 or 6 though. So I guess we'll mark those down. 5, 6, 6, 7, 7, 8, 8, 9. We can't disambiguate that yet. But I could probably say something about this being a 5 means that is a 6. This cannot be a 4, 5 though, so that works. Alright, well I guess we don't know then. Okay, what else do we have? I mean those will be a set of 3 consecutive digits, right? But this can't be 6, 7, 8 or 9. So it must be as low as 5, but it must be a maximum of 5 but can't be lower than 3. So I guess we will mark those, and in fact the same thing happens here. It's can't be 1, 2, 3 or 4, so it's at least 5. See, I don't know what that does, so I can't entirely be sure. Okay. What do we do with I don't know, this one? No, I don't think so. This one, yeah, this one is the one we looked at. This one can't be a 9 because it forces an 8 here. Can't be a 6 because that forces this to be 5. 6 here forces a 5 there. And those digits are greater than 5, but because of the 7 and 9, you can't form 2 digits higher than 5 that are consecutive because you only have 6 and 8, which are not consecutive. So once again, this can't be as high as a 6 and therefore must be 5 or less, which gives you this little chain down here. If it was 4, it would need to be next to 5 or 3. If it were 5, it would not be next to 6, so it would be next to 4. So I guess you have 3, 4, 5 here. Actually, can 8 be anywhere in here? Right, 8 actually can't be in those cells. So those cells can't actually be 7, 8 or 9 at all. 8 here forces this to be 7 or 9, which doesn't work. Yeah, in fact, because 7, 9 is outside, 8 can't be in here at all. So 7, 8 and 9 cannot be here, meaning that at most you have 6, which have to be here. So this again becomes a 3, 4, 5, 4, 5, 6 kind of thing. Actually, because this is at most a 6, this can't be as high as a 5. So you have something that looks like this. Can we do the same thing here? Yes, because of the 1 and the 3, 2 can't be on this set of consecutive digits. Therefore, the maximum you can have here is 4. Because of this being a 5, 6, this is a... If it's a 5, it needs to be next to a 6 because it can be next to 4. If it's a 6, it could be next to 5 or 7. This is at least a 4 already because we proved that 2 can't be in here. So this can't be as low as a 5. So we have something that looks like this. Right, the 7 starts resolving stuff. Alright, let's go back here. 6 here because of the 7. Resolves, this must all be 5. That must be 4. Because of these must be consecutive. 5 must keep going to 6, 7, 8. Do the same here. 3 probably resolves this. Yep. 4 means that's 5, means that's 6. That's 5, which gives us our entire chain back. Alright, we are sort of back. 8 must go there, this must therefore be 9, therefore that is 4. 6 means that's 2, therefore that's 1, therefore that's 6. 5 means this can't be as high as 5, therefore this can't be as high as 4. The chain keeps going. This has to be... well, it has to be 1, 2, or 3 because it can't be a 4. Therefore a 4 here must be there, which gives us our chain. This is therefore a 1. We can do the same here where this must... well, 5 here means this can't be as high as 5. Low, sorry. This can't be as low as 5. This is 6, 7, 8, or 9, but it can't be 6, so it must be 7, 8, or 9. Therefore 6 can only be in that cell, which must increase consecutively. So that gives us a bunch of stuff. Those digits are 1, 2, and 5. 5 must be here. 1, 2 pair over here. This leaves another pair there, which are 3 and 9, I believe, which we don't have. Those are a triple of 1, 3, 9. That digit can't be 3 though, because there's a 3 up here. Those digits are 1, 7, 9, I believe. Yes, 1, 7, 9. 7 can't be there, forming a 1, 9 pair, so those digits have to be 4 and 6. 4 resolves that. Alright, those digits are 5... what am I saying? 5, 8, 9. 5 come in those cells, so 5 goes here. 8, 9 pair here removes 9 from that cell and actually forms a pair of 1, 7 here. Alright, that forms a triple. 1, 7, 8. This can't be an 8, therefore it can only be here in this box. What about those cells? 2, 3, 9. 2 can't be in that cell, so 2 must only be here. Yeah, that makes sense. Okay. Sorry, 7 resolves this 1, 7 pair. 3 resolves this 3, 9 pair. Actually, they keep resolving. This 9 resolves this 9, 8 pair. This one resolves this 1, 2 pair. And we have a bunch of pairs here to complete. These have to be 3 and 2. 3 resolves that. Those have to be 4 and 9. 4 resolves that. 9 here. 4 that. We can do the same here as well. This is 7 or 8. 7 resolves that. This is 1 or 6. 6 resolves that. 1 here. 6 there. And we're almost done. That digit is just a 1, meaning 1 is here, which gives us a bunch of stuff. Actually, whoa. Yeah, this 1, 7 pair should be resolved by this 7. So that's 1. That's 7. This resolves this 3, 9 pair, which makes sense. That digit has to be... well, that's a triple, which is easier to work with, I think. 2, 8, and 9. 2, 8, 9. 9 can't be in those cells, so 9 goes here. 2 resolves this final 2, 8 pair, solving the puzzle in 11 minutes and 55 seconds. I hope you enjoyed that puzzle. I'll see you next time. Bye bye.